Hello, I'm Joe from Robertson Heating Supply. Today, I would like to go over TXVs, the components of the TXV, how a TXV functions in the system, and some troubleshooting to go along with it. So let's get started. So the first thing I want to go is the components of the TXV. So starting right here, we have the sensing bulb. On the top of the TXV, we have the diaphragm. In the middle of it, we have the push rod. And then down here at the bottom, we have the spring. Over here on the side, we have the equalizing tube. Now, TXVs can either have an external equalized tube, like this TXV does, or it can be internally linked to the outgoing line as an internally equalized TXV. So this one, we're just going to go over the external. So basically how the TXV functions is as a sensing bulb which contains a small bit of liquid refrigerant either increases or decreases in pressure, it will push on this diaphragm against the equalizing line pressure and the spring pressure to open this seat right here and allow the refrigerant to come through. This is our liquid refrigerant that has been subcooled down by our condenser to enter here. So if this line warms up, it will put more pressure on the diaphragm, increasing the pressure on this push rod, opening this up and allowing more refrigerant to flow because the evaporator is starved. If the evaporator gets nice and cold, this line starts to get cold, the pressure will decrease in the sensing bulb, pushing on the diaphragm less, and that will allow the push rod to come back up, closing the seat off and allowing less refrigerant to fill the coil, and the coil should warm up a little bit. Eventually it will balance out and it will start working just perfect, and then that way the superheat will be perfect in the coil, depending on the manufacturer and how they set the superheat for the valve. It could range from 8 to 12, 10 to 14. It just depends on the manufacturer. So I put two different modes of operation on there because we have heat pump systems, and some coils aren't rated for heat pumps and some are. So this coil in particular can go either heat pump or it can go just a standard cooling coil. So you can use it on both systems. And the reason why you can use it on a heating mode is because it has a little valve right here which bypasses the refrigerant. In the heat pump operation, the refrigerant flow is reversed through the TXV. If you didn't have a TXV that had this option, there would be no way for the refrigerant to flow backwards through the TXV, and the heat pump would go off on high head pressure constantly and malfunction. So by selecting the correct indoor coil, we can make sure that the TXV has this little check valve in it, so it'll allow the refrigerant to flow bypassing the orifice and the seat right here, and then going up through, pushing this seat out of the way and flowing backwards through the TXV, coming out of the coil through the TXV and then back out to the outdoor unit. So picking your coil is crucial on this. Another thing that's crucial on the TXV is bulb position. You want to make sure that the bulb is typically on a horizontal line. It's not bridging a gap between two fittings. It's nice and flat like this one is. You use the steel clamp that helps to provide temperature all the way around the bulb. And it usually is located between either at the 10 o'clock or 2 o'clock position on a horizontal line. Now, for instance, if it has to be on a vertical line, what we recommend is the nose of the bulb be down and these cap tubes being up. This allows the liquid refrigerant to retain it in the bulb. If you accidentally have this pointing down like this works best to keep it into the bulb. But if it's turned around this way, the liquid refrigerant can run down into this cap tube, and then most of it can be down here instead of in the bulb, and that will cause problems in your diaphragm, how much pressure it's pushing on the diaphragm. You just don't have the refrigerant in here to adequately push and you'll get some different superheat readings that cause some problems. So another thing that I like to do is on TXV valves, I always like to make sure that you install the filter dryer right here at the indoor coil. That way, if there's anything that's in the liquid line, when you first start the unit up in AC mode, that liquid refrigerant will hit the filter dryer right here and allow it to go into here and be all filtered and clean before it gets into the TXV and ruins it, possibly getting debris or something into it. So that's a good rule of thumb, and just make sure that you use the proper filter dryer, directional. If it's a heat pump, you have to use a biflow filter dryer. So just make sure you use that. So the last thing I would like to go over is troubleshooting the TXV. Probably the easiest way to see if the TXV is malfunctioning, especially if your sensing valve has lost its charge, is by using a cup of warm or hot water and a cup of ice cold. This will allow the sensing valve to get its coldest and its warmest. And when it's at its warmest state, it should be open the most. And then if it's cold, it should be closed off. And you should be able to see that change in your gauges. So the first thing you're going to have to do is get your system up and running so it will steady itself. You can kind of note the changes on your gauges where you're at right now. Remove your sensing valve from your line and expose your sensing valve. So the first thing I'd like to do is put it in warm water. So I have a cup of warm water, and this will open it up to its fullest. And then I'll just look on the gauges to see where it goes to. It should open it up, increase your suction pressure. Your superheat should start to go down. This is basically simulating a large load on the coil. So it's going to flood that evaporator coil, bringing the superheat down. And that's what we're seeing right there. So this TXV is wide open. We lose subcooling, lose superheat, pressures go up on the suction side. So on the extreme end of that, we can close the valve off. So I expect if I do this, this will close the valve off, increasing my superheat, increasing my subcooling, because it's gating off that refrigerant at the indoor coil, and usually my suction pressure will go down. And that's exactly what's going on. It's already doubled all those readings, the suction line reading. So knowing that the TXV is responding, I know there's nothing wrong with this TXV. It's opening and closing the valve correctly. So if I got no response out of this TXV, then I would know that something's up with the TXV and it may need to be replaced. Before doing any TXV troubleshooting, the big thing is you want to make sure you have enough adequate airflow across this coil. If you don't have enough airflow, it can also make it look like a bad TXV. I get numerous calls where people have replaced TXVs and come to find out they have not adequately set up the blower performance for the unit, and it's freezing up because it has too low of airflow going across the coil. So I hope you liked our video today. Thank you for watching. If you have any questions, please reach out to our engineering department at Robertson Heating Supply at 330-821-9180 and ask for engineering. Thank you.